All right, I'm going to do this last session about repair options and the limited funding options. And following my presentation, we have a couple of NRCS and state office about how they might be able to provide assistance. There is some limited funding measures from the state and a federal agency. So we're going to talk about the rehabilitation process. The first step will be over here. Typical dam repairs, I'll go through some examples of what normally we find problems with and how they're remediated. Then the funding partners at the end will have a couple of short presentations following mine. Very first thing is you got to do a repair or following a major incident is you got to find the right consultant. And when I say the right consultant, is somebody generally experienced with dams. I think Jill mentioned we're all, most of us are civil engineers, and civil engineers covers a lot of disciplines. And in school, dams is not covered very much in college. A lot of it's a learned experience. So you want to make sure that you talk to different consultants, get their background of them personally and of their firms. They have to be registered in the state of South Carolina. And then your quick proposal, say, all right, here's my problem. Tell me what you think it's going to take to fix it, what the price is going to be, what the schedule is going to be. So you got to understand the design process too. It's more than just one step. A lot of times you got to go out and have a surveyor survey exactly what's there right now, what the dimensions are, where everything's located, what the elevations are. You may have to have a geotechnical investigation. Have somebody go out and drill holes in the ground, take samples of the soil, and send those soils to the lab, and then you do a stability analysis and seepage analysis. And then at that point, preliminary plans and specifications will be developed where the engineer will come back to you and say, here's what we found, here's what we think the solutions are. And at that point, probably meet with the state also. And then after everybody agrees, they develop the final contract documents, which includes the drawings and the specifications, something that the contractor has to go by the remediated dam. And then before you can start the work, DHEC dam state, you have to approve the construction documents. Then during construction, what you have to have is, generally it's the same engineer, they have a resident inspector on site. So when the contractor is building the project, we're doing material testing and make sure the contractor builds it correctly. And at the end of the job, a set of as-built drawings are given back to you for your record, because very seldom is the dam built 100% like the original drawing. There's always little things that are changed, typically during the construction process. So then, once you have that, there might be other permits, not just DHEC permits. There's going to be some environmental permits, and maybe a Corps of Engineers permit if you're disturbing wetlands or a stream channel. There's sometimes stream buffer variances. There are erosion sediment control permits. There's a lot of permits you have to have other than what comes from DHEC. Once you get all that together, you go out and bid it and get more than one bid. Try to get 3 bids if you can. Then you hire the contractor. We'll talk about the construction observation from the design engineer to make sure it's built right. That's critical. And then at the completion of the job, you give DHEC a record of everything that was done, the testing results. You basically have a final report. Here's what was done, here's all the testing to prove that it was done right. So it's a pretty involved process from start to finish. You just look at kind of schedule. This is just a typical showing 20 months of getting a consultant, doing the geotechnical, and sometimes this geotechnical shows a month or two. Sometimes the laboratory testing, you got to get on the lab schedule. That may be a 2 or 3 month process just to get a lab to do the testing. And then the construction, obviously, it just shows a couple months. That's going to be the longest. Is that a 6 month process? Sometimes it could be a couple year process. On your CD, and ASL is how to request professional engineering services. I will say we as professional engineers don't like to bid professional services, but I know you as an owner, price is important. And that is a component. There's no doubt about it. If I was hiring one, that's the price is a component. But keep in mind, qualifications is equally important. We've seen you and other engineers drawings where they do a very conservative design. They may charge you 10% less than the other consultant, but your construction costs may be 20% more. And the dollars you spend are in construction, not in design. So you want to make sure they've done similar type projects, check their references and all of that to make sure you're getting what you're paying for. When do you need an engineer? As DHEC said, it's not general maintenance, but when there's a repair or replacement or a major work like spillway capacity, slope failure, seepage, you need to get an engineer. And like if you got a seepage problem, you're going to get a geotechnical engineer. You're not going to get a structural engineer because it's not a structural problem. So sometimes, depending on the thing, you need to find an engineer that has the right experience with what problem you actually have. Large cracking embankments, slope instability, just name some more of the problems when you actually need to have an engineer. And I think it was mentioned before, if you hire an engineer to fix one problem, you don't have to pay a retainage, but keep that engineer on your smartphone or your Rolodex and all of that. So if you have a problem, particularly if it's, you're starting to implement your EAP, you can call, you have a relationship, you can call that engineer, he knows about your dam, and he can help you through some pretty difficult events. Your dam safety program, I think they keep a list of engineers, your state board of registration, because they have to be registered in the state of South Carolina. State Consulting Engineering Council, there's several avenues. Telephone directory under engineer, that's probably the least one I'd go to. That's an important one. You know another dam owner that had a dam fixed, talk to them. How was that engineer? How did they work out for them? As I mentioned, it's a dam, and a dam covers a lot of parts. It covers a geotechnical, it's a concrete spillway, you got to have a structural engineer, you got to have a hydrologist, a hydraulic engineer to model your spillway, so there's a lot of components you have to consider. You should be familiar with South Carolina dam safety law. You know, that they've got rules and regulations they have to follow. And design of dams and hydraulic structures. You don't want to hire an engineer that's done roadways or sanitary sewers or water treatment plants. They're good at those disciplines, but dams is an entirely different animal. So you have the company itself. And the company may do roadway, water treatment plants, and dams. That's fine. But within that company, you got to have the engineer that can do this sort of work. Ask for references, ask for a list of dams. If they a lot of experience in South Carolina, they should have a number of dams in South Carolina they've worked on. And I'm sure you can come to Jill or John and say, I hire engineer X. What's been your experience with it? Do they know what the hell they're doing? And for sure, they have to be licensed. Now, that's kind of like, if I'm not licensed in South Carolina, I cannot practice in South Carolina. And I can get in serious trouble if I try to practice. Some example of the dam rehab. This is actually an NRCS flood control structure. It had an inadequate spillway. It had an earth spillway that was deemed that if it did operate, it would probably fail. So they actually put over the center of the dam a 2-cycle lateral spillway. So that is, here's the principal spillway, which is a riser. It has a pipe come out downstream. That was the repair. If I would say in today's dollar, that may be a $2 million rehab. Not cheap. This is a bigger one that's ongoing in Virginia. Another NRCS flood control water supply dam. They closed off the emergency spill, which was, I'll say use the right word, auxiliary spillway. That was over here. It was an earth spillway that was studied, and it was found that it would fail if you had the design storm. So that spillway has been closed off, and And now this is the new auxiliary spillway. Here's the riser for the principal spillway right here, the pipe coming out right there. So here is one of the 5-cycle elaborate spillway. That is an $8.5 million project. And part of the cost is this is water supply. They could not drain the lake because that's their main water supply. So they had to put in a sheet pile culvert dam to be able to keep the lake up, because about 20 feet of, you can see where the dam was, they lowered it about 20 feet. So all this is being done below the water level. Erosion protection. Here's a rehab where you can tell it's brand new riprap. They had a wave action problem on this one, so they lowered the lake and put in new riprap around the shoreline. The same project had an inadequate spillway. The old spillway was back in the corner, and now it has a 2-cycle elaborate spillway. This entire project was $1.2 million. Here's a gate replacement. This is a homeowners association on a large watershed. Every time the forecast of rain, a heavy rain, they would come out, the homeowners, and use come-alongs and try to pull up these wooden platforms to start getting water out of their lake. Very dangerous conditions trying to do that in anticipation of the storm. So they actually sued the county upstream of this, because they actually had a lot of sediment coming into the lake. They successfully sued the county upstream of their lake, got some money to actually put in a new spillway. So you can see the same bridge. They took out all this stuff, and this is what I talked before, it's an automatic press spillway. That automatically lowers, and when the water goes up, the gate lowers down, and vice versa. So here it is in the up position. So they spent their money they got from suing the county on a new spillway, so they don't have to go out there and try to pull these wooden platforms up by themselves. I'm thinking that might have been like $300,000. Slope instability, it depends on the size of the dam, the length and height of the dam, but they can get very expensive. Here they're putting in a toe drain. You see the trench here in the pipe. They completely remove all the trees. This is a very heavily overgrown dam. Flatten the back of the dam. When you go out there today, here's the back of the dam. They put sod down there. They flatten the dam. They put in a new riser and pipe. Here's the plunge pool. This was a city-owned dam around the recreation park. But that dam, before they did this, looked just like this, overgrown with trees. You could hardly tell it was a dam. Erosion and outlets. It just gets worse. If you don't do something, that as big as that looks now, in another year or two, it'll be twice that size. So you come in, regrade it, reshape it, and put in riprap. But that riprap actually goes all the way down to the bottom. You don't see it, but it's important to prevent small Grand Canyon from doing it. A lot of times, I would talk about that spillway equation, the H that I told you, that's raised to the 3.5 power. The higher the H, the more water you can pass. So in this case, raising the dam increases that H, or increasing that freeboard. And so instead of raising the dam with earth, because you raise it with earth, you got to put dirt on both the upstream and downstream slope. You start putting in a lot of earth. They put in a concrete wall. It's called a parapet. In this case, it's about 2 foot high. So in effect, they raised the dam 2 feet by this concrete wall, and that H in that spillway formula went up a lot. So that's there. Use this method of raising the dam. You see this a lot because you don't have to disturb the existing slopes or anything. All you got to do is build a little wall on top of the dam. Spillway pipes. Here's a corrugated metal pipe. We talked. They're eventually going to deteriorate. You can replace them. If the dam's not too high, you just dig up the old pipes. Well, if you dig it up, please don't put back in a corrugated metal pipe. Either ductile iron or, in this case, concrete pipe. And the joints are watertight gasket joints. And you want to make sure you get very good compaction along these pipes. You want to make sure you get good intimate contact with the soil with the sides of this pipe. So here you see some Here they're compacting outside of it. You don't want to put that right up against the pipe or crush it. Use a smaller compactor to do it. But that's the proper way of putting in a spillway pipe underneath the dam. Talk about seepage. Here's another example of a boil. Obviously, if you're doing an inspection, you're going to see that. You see the muddy water. That's a level 2 of an EAP. You see that. So we put in these drains. I showed you a picture earlier. The sand and then the gravel, and then they'll put perforated pipe. Typical construction. Years ago, 20 years ago, we used to use filter fabric. It's a cloth-looking black material. We said, hey, we can dig a trench, line that trench with filter cloth, and then put gravel in there. And then the water, the soil can't get into the gravel because the filter cloth, like I said, it's a filter. That works great for a few years. Eventually that filter cloth becomes clogged and the water can't get to the gravel. So you may have a drain that's flowing 5 gallons a minute for 5 years and it will slowly start decreasing down to nothing. We did some dam rehab where we dug down to the top of the filter cloth and water was ponded on top of the filter cloth, but not getting through into the ground. So this is the proper way, more expensive, but this will last a very long time, but the filter cloth will not. To show you before, if you really need a lot of spillway capacity, sometimes you just make the spillway over the dam. And that's been done quite frequently. There's a couple of processes I showed before. You use a roller compacted concrete, but you got to have an area to do it because you're going to make that concrete generally on site. So here's a plant that's blending the aggregate with the water and the cement. They use a conveyor belt, and here they are placing the concrete. It's placed in 12-inch thick layers, usually one layer on top of the other. You don't have to wait for it. You want to do them as fast as you can. And at the end of it, here's one. Generally, it looks like a series of steps, 1 or 2 foot high steps. So here you have a dam, and you got some auxiliary spillway over the dam. So those spillways generally won't operate through a 50 or 100-year storm. So they may never operate for the life of the dam, but they're there for that big flood event. And we showed earlier these articulating concrete blocks. Now, the design of these, even though they come in with cables, and I showed that picture before where you had like 20 blocks cabled together, the cables are there only for lifting up the blocks. They're not there as a structural part of that spillway. Each block is supposed to act independently. So if you wanted to, you could go out and buy a person with a block and just set one block next to the other. But the cables help the installation. They're good for limited depth of water, and you got to have uniform flow of them. You can't have a spillway that's converted. With these blocks, you got to have a uniform flow of them for them to work properly. And in the worst case is conventional concrete. You generally don't want to use because it's more expensive. You got to have joints. You got to have reinforcing wire, but that's another method that you have to consider. Gabions, this is one. Gabions are wire baskets filled with stone, like 6-inch stone and a little smaller. And you see on the back of this dam, these wire baskets are galvanized wire, so they'll last 15, 20 years. But then eventually they'll corrode, and then now you just got loose gravel on the back of the dam. So a limited lifespan. The concrete articulating blocks in RCC will last decades. This has a limited lifespan. Some states won't allow it because of that, because they know you're going to have to replace it in 20 years. This is at Oroville Dam in California. It was in the news a year ago. This is the tallest dam in the U.S. is 700 feet high. Joe mentioned they went to a level 3. They evacuated 2,000 residents downstream of the dam. Fortunately, they probably worried this spillway started flowing. The spillway failed and it got outside the spillway. There's another spillway, an auxiliary one over this side. You can't see. A foot of water started going over that. It started eroding the soil at the base of that spillway. They were afraid if that spillway fell, it would endanger 2,000 people's lives. That's when sheriff decided to evacuate those 2,000 people. They kept water, even though the spillway was being damaged, they still allowed water to go over it. They had to get that water down in that lake. Scale's a little difficult. That's 150 feet low there. Some of it was washed out rock, bad rock. Some of the spillways on rock, but right here was not on good rock. It got out, collapsed, and then ran around this side over here. They're spending over $1 billion, and they're about 99% complete with putting in a new concrete spillway, and then the spillway over here, they're using RCC to reinforce to prevent erosion. So this was not a dam incident, but it was a spillway incident that could still endanger 2,000 people's lives downstream. This spillway was designed by well-qualified engineers at the time, but the design standards today are a lot different. As I mentioned before, this spillway has been inspected by numerous high-quality engineers. If they would have looked at the original design drawing, they would have noticed the weaknesses of this spillway. It had cracks. There was a history of repairing cracks. The drains under the spillway, there was a history of those flowing excessively. There were some warning signs, but nobody really paid enough attention to it. It cost the owner $1 billion plus. Now, if you can't fix your dam, he said the other option is to remove it, or all of it, or breach the dam. And you got to be careful. Here's one where the breach width, you got to make the breach width wide enough so it doesn't still back up. We let part of the dam in place. You put riprap in so it doesn't create an erosion and sediment problem downstream. What happens is, we mentioned before, every dam provides some level of flood control. You breach the dam, now that level of flood control doesn't exist. If there's a subdivision downstream that was used to having that flood control, and now you removed it and they get flooded, you're going to get Joe's attorney back out there, and there's probably going to be a lawsuit. So you run the risk of breaching your dam of people relying on flood control that you're taking away. Not saying it's fair, but that's what you're doing. Now some counties say, hey, if you're going to breach your dam, here's another one, you still have to provide some level of detention, just like a detention pond at a subdivision, for the 2 up to the 100-year storm. So in this one, the county required when you breach the dam, you had to put in a weir wall that had a pipe under it, and it simulates the same outflow for the 2 through the 100-year storm as if the dam was there. So it cost them a little bit more to build this type of structure, but that was a requirement of the county. So in effect, you built back a little dam. Instead of this dam being 24 feet high, now it's 7 foot high. But there's an additional cost to that. Plus, you have to stabilize the old lake bed. It's now mud, and the environmentalists will say, hey, you can't allow all that sediment to wash downstream. But those of you that have owned lakes for a long time, you know if you pull your lake down for 6 months, the lake will grow up in weeds and bushes in a hurry. So what we normally tell owners is, before you breach the dam, drain the lake, wait a year and let the reservoir grow up with grasses and wild and wetland, then breach it, because then you don't have to worry about the sediment because it's already been stabilized naturally. No. During all phases of the project, design and construction, don't be afraid to ask your engineer, what if, or why'd you do this? Again, that's got to be a partnership. You got to trust your engineer. He's there supposedly to help you. So don't be afraid to ask questions. During construction, make sure that engineer, make sure that contractor is building it right. Is he putting in that reinforcing steel? Is he doing the right size steel? And is he putting the right spacing? It's critical. Joe and I can design the best dam, but a contractor doesn't have to build it that way. And once it's built, what's under the dam, what's inside of it, you'll never know. So it's a critical, particularly internal drains. We show this sand and gravel. If you contaminate, say you had a rainstorm and mud washes down inside that gravel, that drain is now completely contractor's got to dig it out and start over. But if he covers that up before the inspector looks and say, hey, I built it just like it shows, your drain will never operate properly. Critical phases of construction. I said before, a lot of times dams, it's not the dam, it's the foundation of the dam that's the problem. So when you build a dam, when you clear it, and you excavate the mud out and the stump, you got to make sure that the foundation is prepared to accept your dam, whether it's earth or concrete. Talk about your pipes being a weak link. They've got to be installed properly. We test the materials. We test the compaction of the soil. We test the strength of the concrete. As I mentioned, an internal drain. We got to make sure we have the right gradation for the sand and gravel, so all that works together as one system. The engineer should, and you, if you're out of take, now with digital cameras, it's easy to take pictures. Take hundreds of pictures and keep them, because if there's a problem down the road, you can look back and say, now I remember over on this side of the dam we found a certain type of rock that was highly fractured or something. So take a lot of pictures and keep them. And then, for your sake, if you have a conversation with the engineer or a contractor, document, keep a field book of exactly what you were told and why you were told a certain thing. All right, this is going to be short, but there's not a lot of funding sources. As I mentioned, if you're an HOA or something, if you haven't already started, collect money and put away a rainy day fund for dam maintenance, and potentially, if you've got a corrugated metal pipe, you know you're going to have to replace it. And those are, we're talking about not $10,000, maybe $100,000 or $300,000. It's not cheap. But start that process of creating a rainy day fund if you own and operate a dam. The ASDSO has been trying for years to get the federal government to create a grant program, not just for cities and municipalities and states, but for dam owners like yourself. It gets close, it hasn't happened. Some states, Virginia has a grant program, will give a little bit of money to private dam owners for design and construction. They may only pay 10% of the bill, but they do that. And other states have that program too, or at least low interest loans. We work with a county in Georgia to create a special tax district. So if you own a lake that has, say, 100 homes around it, is create a special tax district where the county would pay to fix the dam and then tax those homeowners over 30 years. However, we're going to put on your bill $100 for the next 30 years for every homeowner. So they're basically asking, like your bank, which is a big deal. The banks generally won't loan HOAs to fix a dam. So sometimes you can go through your county or your cities and they'll work out special tax districts. And not much here, but if you're like Saluda Dam or something like that, you can get, it's a lot easier to get federal funding. So I got a special tax district. I said ASL is your friend because they're trying to help. Their whole job is to make dams safe, so they have to help you as dam owners. They're working hard to get some federal funding for private dam. Sometimes you can, if you don't have all the money to do it up front, sometimes you can say, all right, you can work a deal with the dam, the state dam fixer. It's going to take us 5 years to come up with this money. How about letting us lower our lake 5 feet? We'll do certain things that we can afford to buy time. Certain states will work with you to allow that. You transfer ownership. You're lucky to say, give it to the county or the city. But then it becomes a public lake. You know, everybody can fish there, everybody can swim there. It's not your private lake anymore. But sometimes you have to do that because your only other option is to do away from the lake. And that's that dam removal. You can decide, all right, my dam is 26 foot high and it contains 60 acre feet, so therefore it's regulated. Go out there and lower the dam like 5 feet and then it's also isn't high hazard. Now your dam is exempt. Now you have to live with a smaller lake, But a lot of people do that. If it's borderline, slightly above that 25, slightly above the 50 acre feet, a lot of people say, I'm just going to lower everything. That's generally, there's still some money involved, but it's not all that expensive. Just what they do to begin.
Well, I can do it.
So that's a good option. I know here in South Carolina, it still cannot be a high hazard dam regardless of its size, right, Jill? That's
That's not a factor in hazard classification. It isn't how much water is released. But
That's right. But if somebody had a 24-foot high dam, 40 acre feet, but there was still a house below the
it would still be a high hazard.
in Georgia, it's not, it's exempt, so each state is different. But here, you'd have to lower the dam, lower the water, such that it's under 25, under 50, and still not a high hazard. So you'd have to do a breach study to see how high that dam would have to, you'd have to lower it so it's not. But a lot of times that's maybe the most economical. So we have the NRCS is going to give a brief slide presentation on what assistance they can provide. And then South Carolina Emergency Management Division is going to do the same. So they both have probably a 10-minute presentation. Joe, you want to do that? Sure. All right.
Oh, here it is. Okay. Okay. Good afternoon. It's late in the day. I will try to zoom through this a little bit. Really want to appreciate Randy and Joe's time. A lot of great information for owners and DHEC for having us. My name's Carter Bagley. I'm the State Conservation Engineer for South Carolina as of 6 weeks ago. So a little new to this. My teammate Stephen Henry was not able to be here today, but he's got a lot of knowledgeable information, and our contact information is at the end. But I'm here to talk about our NRCS assistance programs for dams. We have 4 different types. We fit these in: the Water Protection and Flood Prevention Program, which is the PL 566 we've talked about and referred to many times, the Watershed Dam Rehabilitation and Technical Assistance, and then some emergency recovery programs. Okay, I'll slow down. So we got the PL 566, federal, state, local agencies, local governments. I know there are a lot of individual property owners here. Just really doesn't apply at this point. The program did build about 100 dams in the state, and we can work with those watershed districts to do rehabilitation of them that we'll talk about later. But built for conserve, develop water resources. Now that environmental concerns are such a bigger deal, we're not building a lot of new dams, as you know, and as we've talked about. So it's been a great thing in the past. Other states are doing a lot of different rehabilitation work to them, but we do have to have a partner with state and local sponsors. So we're not a regulatory agency in RCS. We're just here to help, and we have lots of different programs. I'm sure many of you know your local district conservationists, and then they can kind of go to them for help. So in South Carolina, 106 dams. One's resource conservation development. I think those folks went away at some point in time. And then we have the dam rehabilitation program. Mostly in the upper part of the state, as you can see in the map here. Those are the watershed districts. Most of y'all are probably more familiar with them than I am. So. Just a couple slides. They're built majorly because of flooding, to help with kind of flooding issues. I'm from Memphis, Tennessee. Kind of reminded me of being in Arkansas, how we drained, most of Arkansas for agricultural land. Definitely in the flatter part of the state, that was some of the case to help, drain the land for agriculture, but for flood protection also. And talk about safety. I thought of this picture as we were coming up here, and maybe you might choose to do that with your family, but we would not promote that with individuals, I would say, the public, unless it was public. Just water supply, municipal water, so many different uses of the dams and the water structure. So just obvious statements really here. Where does this leave us? Infrastructure's aging all over the country. Nothing new to anybody. But when these watersheds are changing, getting more populated, as we've already talked about, the hazard classifications changing, perhaps going up because of development downstream that maybe the watershed district had no control of. But the water conservation districts must determine the methods of financing for maintenance and rehabilitation. That's, from 6 weeks in, that's just, a big light bulb to me, how we're going to, I don't have any light bulbs, I should say, on how we get these projects funded, whether it's through these folks. You want me to use the mic? Ah, thought I was just talking loud enough. Is that better? Okay. Now I feel like I'm really loud, so, okay. Here we go. Watershed districts, rehabilitation funding. Typically for rehabilitation, you're looking at 35% from that conservation district, and the federal government would come in at 65%. That would first start, and I think I'm jumping ahead of myself, but here, the rehabilitation would start with an assessment of the dam and the improvements that could be made to the dams. That would be the first part in that NRCS can assist those watershed boards and districts with. So part of the Flood Protection Act, which authorized that. So that is something that lots of other states are doing and proactive. The NRCS websites, just looking the last couple of days, had projects up to like 2017, so it's not really up to date today, but there are, you can see a lot that's going on in the rest of the country there if you're interested. So this is some of the things that we can assist individuals. We can provide technical assistance. Our engineering staff is 7 engineers in the state right now, and but we can work through district conservationists to assist and give some technical advice there, and go from there for especially if it's concerned with the resources on irrigation and livestock. And now we're into a different program, our EWP program. This is related to our natural disasters. Obviously, we had Florence come through. Luckily that didn't have a lot of effects on property and infrastructure, and that's mainly what it is. It's not some erosion in a farm agricultural field. It's got to threaten infrastructure. So we've luckily only have a handful of projects that we're going to be doing because of Florence, but it is out there. And then there is an emergency conservation program through ECP that is through the Farm Services Agency. So that is an avenue that just going to be honest, I don't know a lot about the details of the funding of that, but that can be a program if it was an emergency because of a natural event that it can be helpful to an individual property owner or dam. But you must adhere to the program requirements as determined by FSA. A few informative links here. Those are some of the links I looked up before I came in here, but just a lot of good information out there that RCS has and that can be useful to you. I'm thinking this is on the CD also. And then this is the contact information for Stephen and I, and we're just down the street. So come visit us or go visit your local district conservationist if we can be of any technical assistance to you, or your FSA if there's some emergency work that could be we can help you out with. So, and then include the non-discrimination policy here too. So read for yourself. Okay. Now if turn the mic back over to another agency that's going to talk.
Good afternoon, everybody. I'm Alan Fountain with the South Carolina Emergency Management Division. I've got a few hazard mitigation assistance grants I'll talk through. I think I'm last. Am I keeping you from going home? Then I will make this pretty quick, and I'll put my contact information if you have any questions as we do it. I think these slides available if you email me. So with that, we at EMD manage 2 of the 3 hazard mitigation grants commitments available. The third one we don't need to talk about because they don't really fund any dam projects. So these are the only 2 that are relevant to dam safety and to dam mitigation. So we have the hazard mitigation grant program, which is only available after major disaster declarations, which we've had quite a few in the past few years, starting in 2014 with the ice storm, through most recently in 2017, or excuse me, last few months ago with Hurricane Florence. So we get pots of money available specific to the state of South Carolina for mitigation activities after each disaster. So no one wants a disaster, but there are opportunities to help mitigate and build resiliency across the state when it does happen. We also manage the pre-disaster mitigation program, which is a national program that's competitive nationwide. So whereas the hazard mitigation grant program is specific to South Carolina, pre-disaster mitigation is a sometimes larger pot of money that's competitive nationwide, available on an annual basis, depending on what Congress wants to allocate to it that year. Here's the big thing, who can apply for it. So these are the eligible applicants we have to deal with. So state agencies, local governments, that's county governments, municipal governments, or school districts, special purpose districts, our Native American tribe, the Catawba, as well as certain private nonprofits that provide an essential government service. By that, we mean private nonprofit schools, hospital, utility companies. Unfortunately, it does not apply to property owners and homeowners associations. Specifically to homeowners and homeowners associations, you can get a project sponsored by the local government. So you can apply directly for these grant programs, but you can have your project sponsored potentially by a county government or your local municipal government. If then you fall into that category of homeowner or property owner, homeowner association, your first, if you were looking into these grants, your first call after this should be your county emergency management office, somebody at your local municipal office, see if they're interested in sponsoring an application. There's varying levels of interest across the state. Some counties are very interested in building resilience and making sure that their dams are protected, have resilient efforts against breaching. Others, not so much. So it's really picking and choosing. Call your local emergency management office, see if they can push in the right direction, if they're willing to step up and sponsor that application. And if you need a list of those, it's available on our website, scemd.org, or you can email me which county you live in, and I'll give you the point of contact myself. So here's some typical eligible and ineligible activities, just what we've seen in the past. This is not a comprehensive list, just based on what we've seen historically. So what typically are able to fund as eligible are modifications to structural elements that will reduce future damages. By that, we mean modifications to structural elements that are not repairs. So this is strictly reinforcing the current infrastructure that's there. So if your dam was damaged as a result of an event, washed out, we can't pay for repair, we can't pay for rehabilitation, but if it's already in good shape, you just want to make it stronger, you want to increase the size of the spillway, that's something we can typically look to fund. Again, what we can't do, projects strictly related to repair, replacement of dams, unfortunately, that's not something the grant allows for. Also things that don't allow for rehabilitation without increasing the level of protection. So that third bullet there, that's first sentence, without an increase in the level of protection, provides a small window of opportunity if you're doing something as part of repair and want to incorporate a mitigation activity into it. There's a little window of hope there. It's hard to navigate that wording, but we've seen it done in other states, and if someone wants to give it a shot, we will do the best that we can. That middle bullet there, unfortunately, we can't pay for sandbagging or siphon pumps. I personally, Alan Fallon, do not agree with that. I've had a conversation with him many a time that siphon pumps play a large role in mitigation. Your dam won't breach if the water level's not there. But so far, Finn has not agreed with me on that topic. But I'll continue to have that conversation and see what we do. So the funding of our grants are at a 75% cost share. That's 75% reimbursement at the federal level. You, as the applicant, would be responsible for that remaining 25%. Our grants are reimbursement based, meaning that once you get awarded, whatever your project costs may be, we're not going to come with a big, one of those big styrofoam checks, write it out to your name. It's a reimbursement-based grant program. So that money is obligated to the state, and once you complete eligible work activities, we reimburse you 75% of those costs. So if you do have a project awarded, you do need to have some amount of money up front to start covering those costs, and we will reimburse you 75% of those costs as you complete the work. Our application process is very similar to everyone else. So we have a big mailing list we send out like, hey, grant money is available. Please come talk to us about it. Once you get that notification, We'll ask you to submit a pre-application. That's a very general screening process. It tells us who you are, what you're looking to do, and what mitigation activity you're looking at. After we go through that pre-application, if everything looks to be in order, if it looks to be like another project, we'll give you the green light to fill out the full application. The full application gets pretty cumbersome, especially when we're dealing with projects that touch bodies of water or influence watershed activities. So once we get into these activities, the full application becomes pretty cumbersome. There's a benefit cost analysis component of the application that a lot of people get stuck on. So if FEMA is going to invest money into your dam or your federal project, they want to have a return on investment of $1 for every $1 they invest in the project. So there's a benefit cost analysis software that's you have to fill out as part of the application process that requires a minimum score of 1.0 to have your project eligible. And that's where a lot of people get hung up on. It can be difficult with some of these dam activities where they're very expensive and the return on investment may not be there. We've come to find out that the software is really more art than science. So there are ways to get your score to 1. If you're close, you're getting a 0.8 or a 0.7, give us a call. We can probably figure out that last 0.3 or 0.4. But if you're coming in with a 0.02, I'm not sure what we can do. So just keep that in mind if you're looking to move through the program. Once we get that benefit cost analysis as well as the full application, we'll submit that to FEMA, and then FEMA has the final call. So FEMA runs the grant, but it's managed to the state level. And they'll be the ones to make the final eligibility determination at their level after it goes through a wide range of reviews. So the timeline for the 2 grants we do have open, as we just mentioned, Hurricane Florence just happened in September. We have a pot of money that's available from that. We'll be accepting applications now through September 16th of 2019. And after September 16th, they'll all be at FEMA, and you're looking at another 3 to 9 months through the review queues from there before it gets awarded. Pre-disaster mitigation, again, an annual allocation. That application period opened in October. It closes in January 31st of this coming year, and another long review cycle. So none of these grants are intended to be quick turnarounds or be an immediate relief type solution. These are long-term strategic resilience building efforts. So here's just a kind of a timeline window of how much money we typically have available. So our high water mark from hazard mitigation grants was the result of the 2015 floods. We had $48 million, but Hurricane Irma last year, not as big of a disaster, we had $4 million available. For pre-disaster mitigation, again, it's up to Congress how much they want to allocate. 2015, not a lot of money, but if you see this year, we've got $235 million. That's competitive nationwide. So that's a significant pot of money that all 50 states are clamoring over. So the sooner you get your application in, the sooner you get a chance to review it, the better the opportunity you have there. We don't work in a vacuum, so when we make selections on what project we send forward, we work with other state agencies to make sure that we all select projects that build statewide resilience that don't focus on certain areas or communities. So we work with 5 other state agencies to make their decisions. The Office of the Governor, our office, Department of Natural Resources, Department of Insurance, as well as DA. And then each disaster cycle, each funding cycle, we look to build priorities that continue to build statewide resilience and don't focus on the same things over and over again. So we try to expand our horizons on what type of project we're looking to fund, but we typically funded most of the projects we get. So it's not a matter of cutting people off. We typically have just enough projects to fund, and we'll continue to do that based on the applications we fill in. So I've also got some slides and helpful hints here. I think this will go out on the CD, or you can email me and I'll send them out to you. Just some more things to look out for. Be aware if you want to get more information about the grant. And if you do, you can email me directly. If you're interested in submitting a project, please email that topmitigation@emd.sc.gov. That's our group mailbox. Someone monitors it pretty quickly and can get back to you with more information specific to the grant cycles, questions you may have. So we've got 12 people on our staff, and we all monitor it, so someone will get back to you a lot more quickly. But I'm available, and you can just email me, you can call me directly. Hang out for a few minutes if you want to talk after this as well. And I also got Megan Wood's contact information. She used to work in mitigation, but starting in December, she'll be the South Carolina Emergency Management Dam Safety Program Manager. So we also have someone in the dam safety field as it regards to emergency management. So that's all I have. Any quick questions of me before I turn it back over to Jill? All right, thanks everybody.